Hi everyone, welcome to Integral Calculus. Today we explore lesson 7.1, integration by parts, part 1. Number 1, let's take a look at how we do this thing. Integral of x sine x dx d x sine x dx is the integrand. Notice that it is not possible to let a part of the integrand be u and the rest be du. So we cannot use the u-substitution method to evaluate this integral. So we cannot use the u-substitution method. What else can we do? Well, we can take a look at the derivative of uv. Derivative with respect to x of uv. U and v, they are function in terms of x. Using the product rule, we have uv prime plus vu prime. So you will see that uv prime is derivative with respect to x of uv minus vu prime. So now we integrate, and integrate. What we have is the integral of uv prime is integral is antiderivative. So uv minus the integral of vu prime. The v prime, we rewrite that as dv. So integral of u dv is uv minus the integral of v du. Look at the integrand. We can let a part of the integrand be u and the remaining part be dv. And this type of integration is called integration by part. Let's take a look at a few examples, including the example in the idea. Number 2, integration by parts of indefinite integral. A, integral x sine x dx. So how do we know which one is u and which one is dv? The trick is to pick u to be the part so that its derivative is similar. Pick u to be the part of the integrand. So its derivative is similar, such as x to the n ln(x) or tangent x. And we got to pick dv to be the part of the integrand. So that we can integrate to get v. Okay. Here, it makes sense for x to be u and psi x dx to be dv. So du is going to be dx, and v is the integral of psi x is negative cosine x. Using the formula for integration by part, we have uv minus the integral of v du, which is negative x cosine x minus the integral of negative cosine x dx minus x cosine x minus this plus integration of cosine psi x plus c b integral x square cosine x dx. Similarly, we let u equal to x square, dv is cosine x dx, so du is 2x dx, and v is psi x. Integration by part going to give us uv x square psi x minus the integral of v du 2x psi x dx. Now we have the integral 2x psi x dx. We again redo integration by part. U is 2x, dv is psi x dx, du is 2 dx, and v is negative cosine x. X square psi x, using integration by part, we have uv is negative 2x cosine x minus the integral of v du minus 2 cosine x dx. And we have x square psi x plus 2x cosine x minus this plus the integral of cosine psi, so plus 2 psi x plus c. Let's take a look at another example. C integral ln(x) dx, ln(x) u dx is dv. So here du is 1 over x dx, v is x. uv x ln(x) minus the integral of v du, so that would just be dx, and we have x ln(x) minus x plus c. Oh, pretty nice formula for integral ln(x). Let's move on to 3, integration by parts of definite integral. Let's take a look at a integral of 0 to 1 arctangent x dx. Let arctangent x be u, and then dx be dv. du is going to be derivative of arctangent 1 over x squared plus 1 dx and v here is x. So this gets us to uv x arctangent x minus the integral of v du x over x squared plus 1 dx. Oh, for this integration, we're going to use the u sub. No, we did a u here, so we're going to use the t sub. T equal x squared plus 1. So dt is 2x dx. 1 over 2 dt is dx. X arctangent x minus integral. And this would be one over t multiplied to 1 over 2 dt x arctangent x minus 1 over 2 ln absolute value t plus c. So what will happen is x arctangent x minus 1 over 2 ln, well, x squared plus 1 is positive number, x squared plus 1 plus c. And then we can evaluate this one from 0 to 1. The reason why I do the evaluation last, because we'll have to evaluate this one time. Do the substitution, we have a 1 time arctangent of 1, which is pi over 4 minus 1 over 2 ln 2. And when we sub in 0, we just get 0. So that is it. Pretty cool. Here comes another example. B. Integral of 1 to e ln x square dx. This look a little tough, but it's doable though. We're gonna let u to be ln x square and dx to be dv. So here du is, let's use the chain rule. 2 ln x times 1 over x, and dx dv, this means v is x. The integral here will become uv, so that would be a x ln x square minus the integral of v du 2 ln x dx x ln x square minus 2. We know the integral of ln x dx, which is x ln x minus x plus c. So this is x ln x square minus 2x ln x plus 2x plus c. And then evaluate everything from 1 to e. Do the substitution for e, so we have a L needs 1, E minus 2E, L needs 1, and then plus 2E. Okay. Now do the substitution for 1. L and 1 is 0. We get a 0 minus 0 plus 2. So in the end, we have E minus 2. Wow. Pretty cool, huh? Thank you for watching. I hope you like the content of the video. Please like and subscribe to help the channel grow. I'll see you in the next video.